Okay, we're going to start week 6, question 6. What happens to the question 1 to 5? We will solve it later next week. So, as you saw in the practice test of the James that he just shared a few days ago, the last question is about the solving system of the ODE. Now, you see that this one, part A. Let's have a look at the part A, but you won't see something like this in practice, but you need to learn it. So I can write this part A as x prime y prime equal A times xy. So you see that what we want to do just quickly, as in Math2800, we can find the eigenvalues. All right. So the eigenvalues, it's like determinant of the matrix A minus lambda I, which has been written here as well. So after finding the eigenvalues, you see that this guy here. Lambda is equal plus minus third of 2. So then after, we quickly need to find the eigenvector. The eigenvector of the corresponding eigenvalues. So you know the definition of the eigenvector, this one, and also I put a video in Canvas. Like you have seen those videos, like related to the 1120. You haven't seen? Here, all right. If you go here, there are a couple of videos here. Okay. So you can see the linear algebra version. So I have solved an example for finding eigenvectors. This guy, the last one. All right. Back to here. So applying this formula, I get this one. Then you see that the conjugation of this one, this guy, 1 plus third of 2. I will multiply the first row with the conjugation of the 1 minus by conjugation of this guy, which is 1 plus third of 2. So this will give me this guy here, minus 1. So minus 1 here, and if I add this to the second row, this will be 0, and 1 plus third of 2 times this one, which is opposite of this one. So this will be 0 as well. Therefore, from the first row, I can get this equation, and this means if I choose x equal t, y will be this guy, and I can choose my eigenvector, any multiplication of this column vector. So similarly, you can get this eigenvector, and so xy will be the complementary solution of that guy, that ODE will be C1 times eigenvector times exponential of eigenvalue times t, C2 eigenvector times exponential minus third of 2 times t. It's this is the case that 2 eigenvalues are distinct, but you won't get this question. Eigenvalues will be repeated or will be complex. So part B, x prime y prime, this matrix xy. So from here again, we are after for eigenvalues. So eigenvalues, this guy. So we can obtain eigenvalues here using the quadratic formula, will give me just 4. So only 4. So I have the eigenvalue lambda equal to 4 with the multiplicity of 2. So trying to find the eigenvector of this one. So I will get A minus lambda I. I will get this matrix, and this will be this guy. So from here, xt y minus t, and any multiplication of 1 minus 1 will be eigenvector of that eigenvalue. Now, now we want to. So what we want to do for finding the complementary solution for this ODE is this. XY will be C1 times V1. V1 is this guy, times exponential of lambda t, that lambda was 4, plus C2W exponential of lambda times t. So W is the, now there's a debate, W. So W, either we call this W generalized eigenvector, or we call this V sub 2 generalized eigenvector. In this course, this little V2 is called generalized eigenvector, but I'm happy with the W. But whatever their names, regardless of their names, I'm happy with this form. You just have this and you want to find W. But in this course, we are going to we've got the V1t and we are going to find V2. But actually it's the same. We will see. So xy, if I sub these things here, C1, 1 minus 1, e to the 4t, C2, W, V1, purple, t, exponential of. So I multiply this one inside W, e to the 40 plus V2 e to the 40. Okay. So now V2 satisfies in this equation, and in your lecture note Monday. Monday. Yes, Monday. It has been proved that this is equivalent to this 2. So equation 1, this guy, is equivalent to this one. From 2 to 1 is easy to know that. If I multiply this equation by a minus 4i, this will be a minus 4i squared v2. A minus 4i v1 will be 0 because v1 is already eigenvector. But from 1 to 2, we have to write it. It's written in Monday's lecture slide. But anyway, what happens if I just apply equation 1? You'll see that a minus 4i is this one. A minus 4i squared will be 0. I feel that it's coming gradually. All right, so we don't use this one, we use equation 2. So now, so just what I said, explanation about them. So we will use equation 2. So equation 2, minus 3, this guy, a minus 4i is minus 3, 3, 3, v2 equal to v1. So I can try to echelonize this matrix, this augmented matrix. So I will have this guy here, minus 3x minus 3y equal to plus 1. If I choose x to be equal 1, therefore y will be explicitly equal to this plus 1 plus 3t divided by minus 3. So v2 is equal to t x y, this guy, equal 0 minus 1 over 3 plus t times 1 minus 1. So I can choose v2, this one, but you can multiply this guy actually by minus 3. But actually, if you were choosing V1 as instead of -1 or 1 or 1 or -1, can I remember? Yeah, 1 and -1, I can use this one. Any multiplication of that eigenvector is acceptable. Then I will have y equal 1 minus t. So V2 will be this guy. So back to the star, what was the star? Star was this one. So V2, I will replace V2 by what I found. Okay. So if I so V2 will be 0, 1, 0, 1 here, plus t times 1 minus 1. But this purple t 1 minus 1 is equal to this 1 and minus 1. So they will be twice of 2 times e 4t, like that. 0, 1 here. Then I can adjust C2. So instead of writing 2 here, I can just write 1 minus 1 t e to the 4t. And this V2, then I can choose only this 0, 1. You're happy with this. But now let's have a look at this W. If that's V2, instead of V2, I was putting here W, okay? Then at the end, I was just finding V1t plus V2. So whole parentheses would be just W, and we didn't need to think too much. We just needed to sub W and put it here and finished, okay? V2 is just, we found that V2 is 0, 1 plus t plus this purple guy, which is same as this purple guy here. All right. So let's go back there. So here is I've written about like the things that I have just explained. C1 is there without any changing. C2 is this guy. So V2. So instead of V2, I put this one here. All right, this one 0, 1 plus t times 1 minus 1. So e to the 4t, it's here. So this one, but C2, I can change the C2. So it can be changed. Okay, so xy will be C1 e to the 4t plus C2, 1 minus 1t, 0, 1. All right. But as I said, I'm not happy with V2. I'm happy with the W version. The W version is solving everything. Do you have any question? All right. There are other examples in lecture slides, Monday, week 6. And also, there's another example with using W at this link. Okay. So, you will see my handwritings and you will see this. Okay. All right. Question 6 is finished. Let's do time travel. Let's go to the future. Week 7. We are now in the week 7. Question 1. We have been given like 3 linearly independent solutions, but we need to prove it. So we are asked to say that this xt is the solution of this ODE. So x1 is this guy, which is just this one. X2 is this one. X3 is this one. So what we need to say that for the linear independence of these 3 guys, we need to just analyze these e to the minus t, e to the minus 2t, e to the 3t. Although we know that e to the alpha t, they are independent as long as alphas are different. So Wronskian of these three guys can be obtained like this, and it will be a non-zero number. So Wronskian is like this guy, e to the minus 1t, y prime, yz double dash. And also this guy comes in the second column, this guy comes in the third column. Now, this is the x1t, and x1t, its derivative will be this guy. And let's have a look at the right-hand side, a times x1. So a times x1, this guy. So we get this one factorizing minus. We can conclude that this one right-hand side is equal to the left-hand side. As a result, x1 is the solution of the system of the ODE. We can see that similarly that x2 is also the solution of the ODE. x3 is also solution of the ODE. So since we have three linear independent solutions for that ODE, which needs three-dimensional solutions, so we have proved that a linear combinations of x1, 2, 3 are the complementary solution of the ODE. Any question about this? All right, question 2. Part A, we don't solve it because eigenvalues are distinct real. Part B, determinant of A minus lambda I, 3 minus lambda. So we can obtain lambdas, and we can see that lambda is equal 0. So again, obtaining eigenvector, this matrix, this guy, and we can see that this guy will be the first row, the second row can be easily 0, xt, y3t. So v1 will be 1 and 3. Do you have question about this? All right. How we gonna find the generalized eigenvector, which here is called v2, which is satisfying in this equation. So if we have this one, so if we apply this one, so again, a minus lambda I will, it is like this, and v1 is 1, 3. So I address how I can make the second row 0 like here. So from here, 3x minus y equal to 1, x equal t, y equal 3t minus 1. So v2 is this guy, or w is this guy. So I will choose so I can choose t equal 1, and I can give so I can get positive number 1, 2, but you can choose 0 minus 1 as well. Okay. Therefore, the complementary solution will be C1 V1 e to the lambda t plus C2 V1 t, C2 times W e to the lambda t. What was the W? This one. So now, so I sub here C2, V2 is here, T times V1 e to the lambda t. Why I missed e to the lambda t? Yes, because lambda is 0, it's here. Part C, complex ones. Again, trying to obtain 6 minus lambda minus 1. So eigenvalues of the coefficient matrix in part C. So 6 minus lambda, 2 minus lambda, quadratic formula will give me 4 plus minus I. So lambda 1 is this, lambda 2 is 4 minus I. So augmented matrix A minus lambda I is this guy here. If I multiply, I can multiply the first row by the conjugation of this guy, and the second row can be subtracted from that. Okay, I have addressed here. So 2 minus I minus 1. So it's here. So should I put, actually, maybe I should write it here, maybe. All right. So from this guy, so I can write this one, x equal t, y equal 2 minus it. I can, therefore, v1 is this one. So 1, 2, I can decompose to the real and imaginary parts here. v2, so if I have v1, eigenvalues are conjugation of each other. So v2 will be a conjugation of this v1 as well. So v2 comes here. But you can try to obtain it to verify. But so you can use this one, C1 V1 e to the lambda 1t plus C2 V2 e to the lambda 2t. But again, as in we saw that the complex roots version of the Cauchy-Euler, I have illustrated that. And also the complex roots in the constant coefficients of the second order linear ODE. We don't write the complementary solutions as C1 e to the something like I. We don't like to see the imaginary numbers I. So we write it, but we write it in terms of sine and cos. So just a moment. So here again, we use the sine and cos. So the complementary solution, so lambda is alpha plus I beta, 4 plus I. So alpha is 4, beta is 1. So the complementary solution according to the lecture note, not lectures, not lecture slides. In lecture note is C1, Y1, C2, Y2. So C1 will be e to the alpha. So why we can do this cos and sine? Since I explained in the Cauchy-Euler equation, so we don't need to discuss anymore. E to the alpha t, b1, b2, so these were, so following these formulas, so I can just sub there. 1, 2 cos t, sine, c2, and this one. So we can now gather these things here. C1 e to the 40 cos t1, 0, 2 cos t plus sine t, which I have written it here. So C2, guys, the second expression can be written. So you need to write down this one in your cheat sheet, this one. Okay, so let's do alternatively. Again, x prime t is equal to a times x. Okay, so in one dimension, not one dimension, one variable. So let's assume that we are not in the system of the simultaneous ODE. So if we have y prime equal ay, or just y prime minus ay, what's the characteristic equation? Is r equal a. So the answer is y to the a e to the ax. Now, in the solution of the equation, this number 4, this x dot means x1 x1 prime in terms of time, t, x1, y, x1, x2, x3, and so on. Now, the solution of this 4 is equal to x to the e to the at. A is a matrix. So this is not easy to understand. We need to obtain it. So e to the at, did you see the Cayley-Hamilton? Yeah. So I think you have seen Cayley-Hamilton in linear algebra, linearity and continuity. If you haven't seen, you will see in the second course of the linear algebra. Cayley-Hamilton. This is the similar things here, almost similar. So we want to e to the at is equal alpha 0 I plus alpha 1 a. A is the matrix, I is the identity matrix. Our mission is to find alpha 0 and alpha 1. But in this equation, e to the lambda t is like also satisfies here. Instead of a, we've got a lambda. I will be 1. E to the lambda t, alpha 0 t plus alpha 1 lambda. So for the complex versions, we can use 2 lambdas here and get the alpha 0 and alpha 1. If we have repeated solutions, then we've got the e to the lambda, okay? Then you can take a derivative from here in terms of lambda to obtain alpha 1. If you take a derivative from this guy in terms of lambda, this first expression will be 0 because it's not related to the lambda. So you can obtain alpha 1. Now, lambda is equal 4 plus minus I. So we've got 2 lambdas. We can use both of them, e to the 4 plus I t, alpha 0, alpha 1. Did you study these ones here this week?
I think we're doing them next.
Cayley-Hamilton, but I think he mentioned.
He mentioned it, but he didn't show us it. Yeah.
All right. The complex roots, if you don't like the previous method, this method little bit like faster. So lambda is this 4 plus it, so alpha 0, alpha 1. So I sub lambda here. So e to the 4 minus I, alpha 0, alpha 1. So if I subtract 5, 6, so I will get e to the 4 plus I. So this guy here. So 4s will cancel each other, alpha 1 to I. So e to the 4t, e to the it minus e to the minus e to the it, it should remember you sign. All right. If this was plus divided by 2, it would be cos. This guy divided by 2i, it is sine of t. So that's why alpha 1 e to the 4t, this guy divided by 2i, okay, this comes here, and this will be sine t. So sine t, okay. All right, now, this time 5 and 6, instead of subtracting, we can use e to the 4t, e to the it plus e to the it. So this will be twice of cos t. So alpha 0, what we found is alpha 1. So alpha 0 plus, so after simplification, you can get this one, okay? So alpha 0 is to cos t, e to the 4t times twice of cos t. But you can divide both sides by 2. So this will be this one. All right. So Can I write this one again? Sorry, guys. All right, so let's do this. E to the 4t twice of cos t to alpha 0 plus 8. What's the e to the alpha 1t is e to the 4t sine t. So from here to alpha 0 t is e to the 4t twice of that is equal to cos t minus 4 sine t. So this will be alpha 0 t cos t minus 4 sine t. So therefore you can obtain e to the at. So e to the at, another awesome things that I've done is just I substituted very like incorrectly, so I have to rewrite this. So I will upload my like the right things. So yesterday I noticed, but I didn't have time to correct this. We've got 15 minutes. I want to do something else instead. So what we want to do is e to the at. We obtain alpha 0, alpha 1. So our solution is now complete. So x will be e to the at. So so you have to add this guy here, x0, because you saw that y prime a y, then complementary solution is c times e to the a t. Here x equal to c0 or x0 times e to the a t. It's the same as this is complex roots. So you can use this method, Cayley-Hamilton. So it is better. Let's go here. Okay. Okay. So this question. Part A, y double dash plus 2y prime equal plus y is this guy. So I write the characteristic equation. I obtain this one. C1 e to the minus x, C2, it's repeated, so I have to multiply it by a polynomial of degree 1, which is x. So y0, I want to use Green's method. So C1 and C2, they are obtainable by using only complementary parts. So y of 0 is 1, so yc of 0 is C1 equal 1, C1 is 1. So C2 can be obtained as well as 1. So y1 is this guy, y2 is this guy. So from there, we can obtain this Wronskian. So Wronskian will be e to the minus 2x, and it's bigger than 0. Now, can I have anyone can help me about Green's function? I don't remember. All right, so we use this one, gxt, okay, y1, y2, y1t, y1t, y2x minus y1x, y2t divided by Wronskian w in terms of t. So y1 was e to the minus t, and the other guy is x times e to the minus x minus e to the minus x t times e to the minus t divided by e to the minus 2t. So this will be e to the t x e to the minus x minus t e to the t e to the minus x, so can be simplified e to the t minus x times x minus t. Now yp is this one. So this what's the f? So f is this guy here. So this guy here. Now make sure that this why I want to try this one, because in tutorial stations we didn't have this one here. X less than 0, it was like 0. We were just like simply assuming that it's that's a like audio signal. So less than 0, it's like 0. So but 1 here. So again, you apply the same. There's no panic, and you apply the same thing here. You'll see. But I change minus x to the 0 g x t f t dt. So it's like the second boundary of the BVP when solving boundary value problem. So there was b e here to x e t here, but we were just changing and we were seeing there minus. Now here it is again minus x to the 0 g x t. So I will apply this one. What's the e to the t minus x, x minus t, ft, so x between x and 0. So this will be 1, and this will be dt. So we will have the rest of the story. Now, so, okay, this one. So, okay, I will write one more, then we can maybe leave it to the. All right. So now this guy here, 0 x e to the t minus x, x minus t, 0 x between 0 and 1. So it will be 1 minus t dt. Then we can continue this guy. What's this one? Why I keep writing 0? It's because 0 is the initial value. It's because of the y of 1 and y prime of 1 is there. Y prime of 0. So it's because of the problem. Now, we can write this one. Let's assume that x is bigger than 1. Last line. 0. X. E to the t minus x. X minus t. Ft dt. So let's assume, so I want to break down this one is 0. 1 e to the t minus x. What's the, so this guy is between this one is 1 minus t. Plus, 1 x x minus t. What's the rest? 0. 0. So this integral will be all right. So now this guy here, this guy here, and this guy here. So we have 3 YPs. So it's piecewise YP. Let's complete this one in the next session. So I thought that we can complete it, but yeah. Okay. Yeah, I will see you next week, Monday or Tuesday, online. Yeah. All right. Maybe today I will. We can publish your your assignment.
Did we skip